All right, 3.3 is properties of logarithms. Now, it's different than the properties we had a minute ago. This is one where there's basically a set of rules that they're going to give to us on expanding a log expression, and then we're going to take the same properties and do them in reverse where we condense them to kind of work through the parts over here. So anyway, here we go. So this would be expansion properties. And the big thing we'll do now is we're going to show you the properties here in 3.3, get used to them, kind of play around with them, and then in 3.4, because you're going to look at it and go, okay, what good did that really do? Right now, you're not going to see the finished product of this one. When we get to 3.4 next time, that's when we actually use the properties, because they're going to have us we're going to have to expand it or condense it so we can solve it for x. So it's one of those things of just showing you what we're going to do, and the next time we'll actually solve it and get an answer off of the problems we're going to do. Okay, so for expansion properties, and we'll show you both here, because we'll write it in log form, but we'll also write it in ln form just so you can see what both of them look like. It basically is this. If you have log of, and the base is not necessarily important for this one. It can be any number that we have. But if you have two things multiplied together, if you have m times n, whatever that number may be, if they ask you to take this property and use expand this, then what you're going to wind up doing is you're going to take whatever these two things are, and expanding means basically you're going to rewrite this expression and you're going to use log more than one time. Maybe 2, maybe 3, maybe 4 times. But where you have log of m times n, you're going to take the log of the first thing and then add that to the log of the second thing. And the only difference that you would have if that was in ln form would be the ln of m times n. But when you expand it, it'll still be the same thing. It'll be the ln of m plus the ln of n. And we'll come back in a minute and give you some numbers. Let's just show you the three properties first. And then once we got the three properties, then we'll go through and expand all these and just let you see how it looks here. Okay, second property. That instead of the two numbers or the two things being multiplied, if you divide them, if you think about it for a second, if multiplication becomes addition, then division will become subtraction. Yeah. So it's going to be the log of m, same base, minus the log of n of the same base. Again, the only thing that you do different for this one is if you put it in ln form, it's the ln of m divided by n, but it's still going to be written the same way. It's the ln of m minus the ln of n. And then the last property. If you have log of, and again, the base really doesn't matter what it is, but if you have some number or something to a power to expand it, now this is the one where you don't actually use the log word more than once when you rewrite it. This one, it's more of a, when you really call this an expansion, this is more of a, it's more of a rewriting, really is what this one is. All you're going to do is take the power that's here and bring it out front, so it's basically this number multiplied by this log expression. So this one is the kind of the weird one in the expansion group because you're not really expanding anything on that one. Okay, and if you do it in the ln form, Same thing, it's the ln of something to the power. That would be p times the ln of m. And with those, sometimes you'll have where they may actually write this part out. Sometimes, depending on how you expand those problems, you might actually have to use a parentheses to show that you're multiplying it by multiple things in there. So just realize that it could be written a couple of different ways when you're going through this. Okay, so very first thing they're going to have you do is they're going to give you this problem and say, all right, what I want you to do is just to take this thing and just use the properties to expand it. What they're going to ask you to do is, once you do the expansions, they're going to tell you, if it's possible, without using your calculator, like we did in the last section, see if you can, if there's a part you can simplify on this one, that where the bases match up, go ahead and simplify where the bases match up and you get the answer. If it's something weird where the bases don't match up, don't worry about it, but, you know, if everything works out correctly, go ahead and work this thing out. So, let's tell you, here's what we're going to do. We're going to expand the expression. And then they'll say something like this, where possible, evaluate without a calculator. And the last thing we'll do in the section, here in this section, is we'll come back and show you how you would actually use your calculator to solve a log expression when the numbers are there. Okay, so for this one, we're going to do log of 7x base 7. So here's one where it's close, because we've got sort of the right numbers like we were looking at back in the last section, because these two numbers are here, but we've got this extra x here. So that extra x is kind of throwing this thing off a little bit. So that kind of messes with doing our properties like we did before. So here's what they say, all right, if we're close on this one, let's go ahead and expand this thing. So we're going to go ahead and rewrite it first. So because it's 7 times x, when you expand this one, that multiplication becomes a plus. So it's really the log of 7, base 7, and the log of x, base 7. Okay, and then here's where hopefully it jumps out at you where they want you to use the properties we're talking about, where we evaluate without calculating. These two numbers are the same. So again, technically this would be 7 to the first power, so this would just be a 1 plus the log of x base 7. So they're having you do two parts. One, they're having you expand it, but then the second thing they're also asking you to do is, okay, just remember, if you have some parts where the numbers match up, just go ahead and rewrite that part of it to do what you can do. And somebody may be asking, well, what if that was 7 and this was 70? Nothing you can do right now. In a minute, we'll show you how to use a calculator to get that. But for this part, they're saying, all right, don't use a calculator, but if something obvious jumps out at you, simplify that part. If it's not obvious, don't worry about it. Some of y'all may be saying, nothing's obvious. Well, okay, that's just, just do the best you can is what it's kind of asking here in this case. All right, let's go log of x to the 7th power with b as our base. Okay, there's nothing multiplied or divided with those two parts, so this is the one where you're not, it's an expansion, but it's more of a rewriting. That all you're going to do is you're just going to take the 7 that's in the power, drop it out in front, so it's 7 times the log of x. And for that one, there's nothing that you can really simplify for that one, so it's just a rewrite problem. Okay, so here we go. Log of x squared y with b as the base. Okay, and for that problem, there's a couple of things. First, we've got x squared times y. So really you have x squared times y. So again, very first thing is that's going to be a plus. So it's the log of x squared plus the log of y. And the second part, the log y is okay because that one's fine, everything's good there. But because this one has this exponent that's here, you've got to go one more step with that one. That 2 that's in the exponent needs to be out front, so it's a product, or it's 2 times the log of x with b as your base. Okay, now somebody's probably thinking, well, oh, okay, because sometimes we'll run through this problem and people go, well, how do I know where that power goes with what it's kind of going with here? Here's one where it's a little different problem, but the power would be not with just one part, but with both parts. So let's say it's the log of xy squared with 5 as your base, where that it's both x and y squared on this part. Okay, and for this one, you can do this one a couple of different ways. But the very first thing is because it's the entire, you do have the multiplication here and you also have the power. So because it's both of them, it's the whole expression of the power, you could take the 2 out front first and make it so it's 2 times the log of x times y, base 5. Okay, and then now that you've got the multiplication, then you could take that multiplication and break it up as a plus. So it would be 2 times the log of x plus the log of y. Yeah, and you could also put the 2 in front of each one of those. So it could be 2 log of x and then 2 log of y. So either way should be okay. So where the 2 is and which one it goes to will make a difference of how it is. That for the previous problem, it was only x that was squared and not the y. So the 2 only went with the x. This one, it was both of them squared. So the 2 goes with both the x and the y if you kind of go through that part. So it depends on which one is a power. If it's both of them, then it has to be on both parts. If it's only one of them, then it's only going to be on one part. Okay, one part here that's a little tricky, one part that's hopefully not a little bit tricky. We've got the log of the square root of x over 64, and this one's base 4. So you have the log of square root of x base 4. Because it's the division, then that becomes a minus problem. So you've got the log of the square root of x minus the log of 64, and both of those are base 4. All right, now here's where you got to go back to what we were talking about in the previous part, in the previous section. That when you have the square root of x, that if you have a radical, it's going to be a fractional exponent. So that really means this is log of x to the 1/2 power. So for the 1/2 that's here, again, that's only with the x, so that's going to be 1/2 of the log of x base 4. Minus, now here's one where that sometimes this is a problem, that sometimes this one doesn't jump out with you. And we'll come back to it in a minute and show you where that you could use your calculator on this one. Maybe I should have done that first. But this is one of those problems that sometimes people won't get this one, they'll just leave this one here because they'll go, okay, we're good. But if you actually think about 64, I'll do this one on the side. It's a root of 4, because 4 times 4 would be 16. And if you did 16 times 4, that would be 64. So technically 64 would be 4 to the third. So for this one, you've got the log of base 4, but it's 4 to the third. So again, the bases are the same. That's going to make that part just a 3. So this would be 1/2 log of x base 4 minus 3. Now, again, if you're going through this one, and sometimes people go, okay, I don't know if that number is going to work or not. In just a second, we're going to come back and show you how to use your calculator. That if you get a number and you're not sure, if you look at it, you go, I don't know if that's the same basis or not. We'll show you how to use your calculator to check it and see, because I know they tell you not to use your calculator, but sometimes you just don't know the numbers because you just don't know. And that's okay. You just use your calculator to check and see if you actually get a whole number answer. If that had been, in a minute, if we'd done this problem and simplified this when it was 3.189437, you would just go, I don't have to worry about it. I'll just leave it written as whatever the log expression is instead. All right, a couple more of these, and then we'll condense, and then we'll show you the part of how to use your calculator. Is that 5 problem back here? Is that number 5? It was. Okay, so number 6. So let's do the log of, again, base really doesn't matter in this case. It's whatever it wants to be. X squared y over z squared. Okay, so you got all kinds of different parts on this one. And this is one you can break it down a couple of different ways. But you've got the multiplication up here because you have x squared times y. So the very first part is you'd have log of, and this one is base b, it's x squared, and then plus the log of y. And even though it's the whole thing divided by z squared, you're only dividing it one time. So as soon as you've got these two things, because if the z squared wasn't there, it'd just be log of x squared y, it'd be those two things in there. But because of the division, then at the end, you can just go ahead and tack on the division basically means subtract. So that's minus the log of z squared. And then one last thing to do, because you have the exponent here, bring that exponent out front, so make it 2 log of x plus the log of y, and then for this one minus 2 log of z. And technically, you could move these around in different places. Like you could flip-flop where these two are. You could have minus 2 log z plus the log of y there. But most of the time they tend to put the multiplication first, just because most of the time you're going to multiply together first before you go back and do division. But, technically you could do this one where it's this divided by this. And I think they'll do that just so there's not a confusion of, well, how do I know it's not that times that in the bottom? If they were going to have both of them in the bottom, they would do that. So both of them it'd be minus both of them, not just the one piece. So I think that's where they generally try to keep it so that they put the multiplication first and then the division at the end, so that if it's got a minus in front of it, it has to be in the denominator. If it's got a plus, then it's basically the numerator. Okay, and one last one. We didn't do anything with ln, so let's throw one with ln here. Let's do the ln of third root of x divided by y. Okay, and very first thing is there's not a power here, so very first thing is just to realize that that 1/3, or that the cube root really is the same thing as the 1/3 power. So that means it's the 1/3 times the ln of x. And because it's divided by y, that means it's minus the ln of y. Again, you could take that 1/3 and distribute out to both of them. So it would be 1/3 times the ln of x minus 1/3 ln of y. I'm good with either one of those two answers, yeah. Whether you distribute out the 1/3 or leave it together. Online homework, they probably want this one, but sometimes they'll let that one slide too. If not, they'll say you have it in the right form. You just need to distribute out your power or something like that. So they should kind of hit you there. Test-wise, I'd take either one to be fine with. Okay, so there's using all your expansion properties to stretch it out where you use log or ln more than one time. Then they're asking you basically go in reverse that we're going to condense. And with the condensed part of it, you're going to rewrite it with log written one time. So with the condension part of it, you're going to start with log or ln written 2 or 3 or 4 times, and you're going to take the properties you have in reverse and bring it back together so that you only use the log one time. So whenever you see condensed, basically just go backwards. Instead, where that you had a subtraction problem in your original part, now you're going to make it a division problem. If you have a plus, then you're going to make it a multiplication problem. So for this one, we'll go 2 times the log of x base 5 plus 3 times the log of y base 5. Okay, so this 2 goes with the x, so basically the first thing is you're going to rewrite that one where it's x squared. With the 3, take that back out to a power and make it y cubed. And because of the plus sign in the middle, that basically means it's going to be multiplication. So it becomes a log of x squared. Now, and for this part, you really don't have to put the dot for the multiplication because it's x squared times y to the third. But in that case, you really don't have to have the dot, so you can just put log of x squared y to the third. I don't think they would count off for putting the dot there for multiplication, but I think they just kind of assume that you don't have to put the dot for multiplication there. Okay, for number 2, we'll go 4 times the ln of x plus 6 minus 3 ln x. And similar to the first part, you've got the 4 that's out front, so that becomes x plus 6 to the 4th. That one becomes ln of x to the 3rd. And because the minus that's here, I'm just going to take those two parts and instead of multiplying together, division. It's the ln of x plus 6 to the 4th power in the numerator, and then x to the 3rd in the denominator. And for the last one, we'll do log of x times x squared minus 1 minus the log of 7 minus the log of x plus 1. No base on these, but again, if you're just condensing it or expanding it, you're not really worried about the base because you're not solving anything yet. The solving part really is what we'll do next time when we get to 3.4, because that's where we actually put everything together and solve it. So starting right off the bat here, you've got log of x plus log of y. That means those two things have to be multiplied together. As soon as you see the minus, that's a division part, so that's divided by 7. Because that's got a minus in front, that means it's also divided by x plus 1. And that would make it log of x and x squared minus 1 on the top. And on the bottom it would be 7 and then x plus 1. So here's one where if you leave the answer there, this would be one where the homework would probably, the computer in the homework would probably tell you, you've got the right answer, but you might need to simplify a little bit more. Once you've got, because basically the log here, this is almost like one big giant fraction. And if there's anything inside this one that you can simplify, they're asking you to go ahead and simplify this one a little bit. There's one small thing you can do here. Because you have the log and there's not really much there you can do with that part. But nothing you can do with the x, nothing you can do with the 7, there's nothing you can do with the x plus 1. But we have this x squared minus 1 that's here. If you had x squared minus 1, you could factor that off as x plus 1 and x minus 1. So if you were to factor that x squared minus 1 off to get it here, well, now you have x plus 1 and x plus 1. You could cancel those two things out. And make that the log of x times x minus 1 over 7. You could, I mean, that would be okay. And if you were, to me on the test, if you did that, if you went ahead and said that was x squared minus x over 7, I would take either one of those two answers here. Probably if you left it like this is your answer here, that would be one of those where the most I would take off on that one would maybe be a minus 1. That's one where I'd still kind of be, maybe not even take off a point on that one. Because you did everything together. And that might even be a problem where I would say, once you bring it together, if you can factor or cancel anything at the end, factor and cancel. I might even give you a little hint for that one because most people just want to put it together. They've done what it said to do and they're not really seeing that part of it. So that's one of those questions where sometimes, it's good that you can do that, but sometimes, you will kind of miss things because you're worried about doing just the one thing it said and not worried about the factoring on that one. So that's one of those, it's almost getting a little ticky-tack to me on that kind of a question. But they will possibly throw that at you, so just kind of be aware of that on that part. All right, and then the last thing in section 3, here's where you get to use your calculators. And they're going to tell you to use common logarithms. Or they'll tell you to use natural logs, because you can kind of do both here. So this one, now, for this part of it, there's a good chance on these that all the other problems we did before, it came out the answer was 1 or 7 or 3 or something like that. This is one of those problems where some of these answers you might get that, but at least half the answers you're not going to get this. So when they tell you to evaluate it, they're going to tell you to round to 3 or 4 decimal places. In this case, I think they said 4. So we're going to round to 4 decimal places when needed. Okay, so here's the one property that they have when they go through this thing. So it's the change of base formula. So when they talk about the common logs or the natural logs, we'll kind of go through this one. Here's the big thing that now it's changing as we're going forward because now they're starting to program calculators where they're a little bit differently. But up until, pretty recently, everything that we did it was on base 10. We have 10 fingers, so all of our number systems, it's all on base 10 system. So most calculators up until lately were always using one number. You had base 10 or you had base E. That was the two things that you went through on these. So here's what the change of base formula said. Was that if you had log of, let's say, well, let's just do it this way. We'll give you some numbers in a second. Let's say you had the log of M, some number, and your base was B. If these two things were the same, we had the shortcuts properties for it. But here's what it says. If these two things are different, then this can equal the log of M base 10 divided by log of B base 10. Now, and the only thing with this is don't get this confused with the expansion and the condension properties where you could take the division part and rewrite it. This is not for this part of it back here. Here's what you got to kind of realize that when we're looking at this one. This is not the log of M divided by B, because sometimes people kind of get those two confused a little bit. If we're doing something like that. So just realize that this is not log of M divided by B. This is a total rewrite of this thing. That if you have the log of M base B, then you're going to rewrite this with log of M base 10 and log of B base 10. And then as long as it's base 10, you can use your calculator. And again, some of the newer calculators that are coming out with now, they're starting to tweak it where they'll let you use different bases, but just on the same, so we can kind of keep it the same for everybody, because this is true for every calculator. Every calculator that you have that has the log button, it will automatically calculate a number with base 10. So if you wanted to do, if you punched in the log of 5, it's automatically on your calculator going to put base 10. So if you get a problem that is, here's what we're throwing at you. Let's say this is log of base 5. And we're going to do log of 10, but instead of 10 being the base, if this was base 10, we know this answer would be 1. But if this base is anything other than 10, we don't know what that answer is. So here's what it says with the problems, and we're doing. Let's don't use 10. We'll go ahead and use 10. What this says is then you can take log of 10, base 10, and divide that by log of 5, base 10. Now, here's where, on your calculators, this is where everybody's calculator is going to be a little bit different, and you've got to play around with it. But as long as it's base 10, you can just take this thing and do the log of 10 and tell me what that number is. And again, everybody's calculator is going to be a little bit different, so we've just got to find the correct order of how your buttons work on these. But the good thing about the log is either you're going to hit log and then hit 10 and hit enter, or you're going to hit 10 and hit log and then hit enter, just depending on the calculators. Okay, so if you do log of 10, that should just be 1. If you do log of 5, 0.698970000, all of this stuff that's there. Okay, so that's 0.6989700. We got all this stuff here. So now we got to take 1 and divide it by that number. Should be 1.4307 if we round that off. 1.4307. Now I think now in that case log 10 worked out okay, but we'll give you one here in a minute where it doesn't kind of work out with that one. Okay, so that was the first. Let's give you a couple more of these. So let's do the log of 17, where 0.1 is your base. Okay, so calculator-wise, that means you can do the log of 17 divided by the log of 0.1, where again, you're going to use your calculator where they're both base 10. Okay, so 17 log, I'm getting 1.2304. And to get the correct answer, leave that number, all those dots behind it, leave all that in there. And then we're also going to do the log of 0.1. Do I get -1 for that one? Okay. So this one works out kind of good because if you take this thing and divide it by -1, that just means the answer is going to be -1.2304. All right, now the other thing, and this is something that will come in handy more in section 4, but if they give you a problem, you can also do the same thing, and this is where it's good practice here. Let's take this same problem back up here, the very first problem, where we had the log of 10 divided by the log of 5. You can also, to kind of spin off of what it was saying back up here, when the change of base formula, basically it says you can take this base number that's here, and you can rewrite it so you can use any number you want to use. Now, we're going to use base 10 because that makes sense because it's calculators. But if you had a problem like this and you wanted to rewrite this problem with base 5, you could take that problem that was here, or we could even take this one. Let's say you wanted to rewrite it so it was log of base 17 in both cases. You could rewrite that with any base you want to. Now, you may say, well, that helps us here, but that doesn't help us here. Exactly. We're kind of back in the same thing. But the change of base formula says that you can rewrite that with any number you want to. Now, it makes sense for us to use base 10 because it uses calculators. You can also do the same thing using it with base E to rewrite it. And again, if you're using base E, that basically means you're going to use ln. So we could take this same problem we've got here for number 2, where we did the log of 17 and the log of 0.1. You could also do that same problem and take the log of 17 with 0.1 as the base, and this time use ln. So now we're going to do the ln of 17 divided by the ln of 0.1. Now, by using the ln, it's going to be kind of two things here. This number is going to be different, and this number is going to be different. But when you get to the final answer, it's going to be the same final answer. So if you check it with ln, ln of 17 is 2.8332. And the ln of 0.1 is negative 2.302. 585, all of this stuff behind it. Okay, but here's kind of the neat thing with this one. If you divide those two numbers, the answer is going to be negative 1.2304. And what they're kind of showing you is, okay, you can take these numbers and rewrite it any way you want to. So you can rewrite it with log base 10 to use your calculators, or you can even do it with log base E and still use your calculator. Because you can rewrite these problems up here any way you want to with any base that's here. So you could basically say that, you can make this base X and make this base X. You can change that to any number you want to. But for when we're using our calculators, it makes sense to rewrite with either base 10 or base E, because all the calculators that we have, all of them will use base 10 or base E, and some of the fancier ones will let you use any number you want to for base, and let you use your calculators. Now, in section 4, they're going to have some parts where they're going to tell you you can solve it anyway. Some parts they're going to tell you you have to use ln for these problems, because they're going to say rewrite this answer using the answer in natural log. So you have to get used to being able to go back and rewrite it that way. Let's do one more here where we do it with the ln's. So for this one, we're going to rewrite it and evaluate using ln just so we can kind of see what's going on here. We're going to do log of 63 where pi is the base. Okay, so where they're going, and again in section 4, which we'll get next time, some of these they're going to tell you you have to use the word ln for these. So for that one, it would be the ln of 63 divided by the ln of pi. And sometimes on the answer they would tell you, they may actually have you do two things. One, they're going to tell you to rewrite it using ln, and then after that they'll have a part B where they'll say, all right, now tell me what the answer is in decimal form. So they'll ask you for both of those. So if we do the ln of 63, that is 4.143. And we got all that other stuff behind it back here. If you do the ln of pi, and this is where you have to be careful because you have to use more than just 3.14. You have to use 3.14159. Hopefully you have the pi button. If not, you've got to take it out to a little bit longer there. So if you have the pi button, use it. If not, use 3.14159. Take the ln of that. It should be 1.144. Got a bunch of stuff after that one. So then we're going to take the ln of 63. Take those two numbers and divide those two answers and see what you get there. Let's see, I was going to say 3.6 something. Okay, I got 3.6193 on that one. That again, you've got to take these numbers and run them all the way out when you do that division. If you just stop here, if you just stop with those three decimal places, it's going to throw the answer off just a little bit like you were saying there. So that's when you got to leave that whole entire thing, ever how many decimal numbers you can get. If it's 8 or 10 or 12, leave that whole thing in there and then divide it by this whole number, run out to 8 or 10 or 12 decimal places, ever how much it'll get to you.